Hello, learners of mathematics. I'm excited to share with you that my upcoming videos on this channel will be focusing on exam preparation questions, particularly those related to challenging topics. Whether you're studying for an exam or just looking to improve your understanding of mathematics, these videos will provide you with the tool you need to succeed. Stay tuned for tips and tricks on tackling even the most difficult questions, as well as step-by-step explanations of complex concepts. Remember to practice, 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 and don't be afraid to ask questions or seek help when you need it. I look forward to helping you on your journey towards mastering mathematics. Let's start with limits of accuracy, bounds of accuracy. You will find this on page 24 in the mathematics textbook y equals mx plus c to success, grade 10-11, part 1. Now, in the textbook, you will first see one approximated number, which is usually not so difficult. My focus in this video is going to be on two approximated numbers that you do a calculation with. You either add, subtract, multiply, or divide. Now, the most important thing, first find the lower bound and the upper bound of the individual numbers before you do the calculation. Now, I divide it into two parts. In part 1, I'm going to concentrate or just focus on addition and multiplication. And in part 2, I will focus on subtraction and division. Okay. But this I took from the textbook. But let me just refresh your memory. Say if you must add two numbers. So what are the lower and the upper bounds of the sum of the measurements 6 and 2, each correct to the nearest centimeter? Now, if you just add the two numbers, it will be 8. But because these numbers are approximated to the nearest centimeter, you must say 1, divide 2, then you find your upper and your lower bounds. Now you start playing around with the numbers. So if you say upper plus upper, you get 9. And if you start saying upper minus this lower, you get 8. Then lower minus this upper, you get 8. And if you say lower minus lower, you get. So to get the smallest possible one, I will go with upper, no, not with upper, sorry. Let me just go. I will go with lower. And to get the biggest possible one, I will go with upper. Okay, and that was for the lower. So what I'm going to show you as soon as I do the sums, and this two stands next to each other. It's almost like a parallel movement. I went to the top, and I went to the bottom to get the 7. And it's exactly the same what happens in multiplication. Again, if you say 6 times 2, that is going to be easy. 6 times 2, that is just going to be 12. But now I start playing with the numbers. So if I'm going to first find the upper and the lower, and then I find the product. So again, let's go upper times upper. I get this. And then I say upper times this lower. I get this. This is middle values. And then I say this lower times this upper, and I get this. And then I go for the lower times this lower, and I get this. So this is my smallest, and this is my biggest one. Again, it's almost like saying it's going parallel, because it's upper, and for the biggest, and lower for the smallest. But I'm going to explain this by bringing these tables into examples. And let's start. Let's go to the first. Okay, I'm going to start with this example 1. Now, if I'm saying to you, I give you a formula. There's the formula. Okay, let's just get a better color to see. There is my formula. And I say W is 12 correct to the nearest whole number. Now, as soon as I say a whole number, I refer to 1. So it's 1 divided 2, it's 0.5. So I will add 0.5 for the upper and I will subtract 0.5 for the lower. And that's what I did there, okay? Upper, lower. Let's go on. And now I'm going to say h is 4, okay? And it's also correct to the nearest whole number. So it's staying that. So it's again, add 0.5, subtract 0.5. So there is my upper and there is my lower. Okay, now remember, this number 2, it's almost like it's a constant. It's not approximated. So it's very important that you just leave that 2, okay, which I did there. And now I can start. So if I want to get the addition, okay, what is the question? Work out the upper bound. They don't ask both. Sometimes they ask just that, meaning the upper bound for this calculation. Okay. So if I want the upper, and now this is where my story comes in. If I want the upper, then I just go upper plus upper. It's almost in a parallel movement. Do you see that? So I will just say 12.5 plus 4.5, the two uppers, and I just multiply it with 2, and I get 34. This is very nice because it's an exact number. If it's not an exact number, leave it unapproximated. That I see from the question papers. Okay. What do I want you to do? I want you to do I want you to stop the video. I want you to do question number 1. As soon as you are finished, you can continue the video. Okay. Let's start. Question 1. Calculate the upper bound for the following calculation if each of the numbers is given to 1 decimal point. Now, 1 decimal point is actually very easy because 1 decimal point, it's not significant. I'll do that in the next question. It's always going to be 0.1. If it's to 2 decimal points, it's 0.01. Okay, so I'm going to always divide it by 2, and I'm going to get 0.05. Okay, so I'm going to add that for the upper bound, and I'm going to subtract that for the lower bound, and let's do it. So take the 1,35, remember what I said, the note, always first find the upper and the lowers before you go into the calculation. Okay, so for the upper bound, and then I have my lower bound. So if I add, there I do that, for that one, what am I going to get? I'm going to get 1.355. And if I take 1.35 and I subtract 0.05, I'm going to get 1.345. That is my numbers. Okay. I just want to rewrite it so close to that number. Okay, so 1.345. Okay, now I'm going to, let's just move it a little bit to this side. Now I'm doing exactly the same. 7.58. So 7.58. Because it's also 1 decimal place, I'm going to do exactly the same. I'm going to add for my upper and I'm going to subtract for my lower bound. So for my upper bound, I'm going to get 7.585, and for my lower bound, I'm going to get 7.5775. Okay. And now, okay, so let's start with the calculation. Here is the calculation. Do you see that? So basically it's just plain, and I want the upper bound. So to get that upper bound, I'm just going to say upper plus upper. It's that movement that I'm going to do. Do you see that? So I'm just going to say 1.355 plus 7.585. And that is going to give me 8.93. And it's the exact number, so I just leave it like that. If it's not exact, then write the full calculated display. We don't approximate at limits of accuracy. Okay. I want you to do exactly the same. I want you to stop the video And I want you to do number 2. Again, you can continue the video as soon as you are finished. It's always good to first try it on your own and then to just check if you are correct. Right, let's start. Number 2. Calculate the lower bound. So remember, this was upper, this is lower. For the following calculation, if each of the numbers is given to 2 significant figures. Now, significant figures, as I did from page 24 in the textbook, is usually more challenging because it depends on every number. So if you take, let's start, 75, and that's correct, to 2 significant figures. Then, what I usually say always, and you can watch my other videos on the channel, the basic ones. So it's 1, 2. I mark the second position. And then I fill with zeros, but I put a 1 in that position. So basically, it's just going to be 1 divided by 2. So it's going to be 0.05. And I will add for my upper, and I will subtract that for my lower. Okay, now 210. So 210, it's also correct to 2 significant figures. Okay, so again, let's work again with that principle. So it's 1, 2. I put a line. I put a 0. I put a 1. And I put another 0. And what is standing there? There is standing 10 divided by 2. So it's going to be 5. So I add for my upper and I subtract for my lower. Okay, and now I can start with the calculation. So what is the calculation? It's 75. Okay, but let's start with it like this. I'll just show you the calculation there. And they want the lower bound. So if I want, before I can start with my calculation, I first have to bring that in. So let's do that. Let's going to say 75. We didn't find the upper and the lower yet. So this is the upper, this is the lower. And it's going to be the same with 210. It's going to be the upper and it's going to be the lower. Okay, so it's going to be 75.5 and 74.5 because I'm adding and subtracting that. And then this one, 210. Now I add and subtract this. So it's going to be 215 and it's going to be 205. Okay. So basically, okay, now I'm going to start with the calculation. So if I'm going to do this, I'm going to continue. I'm now going to work with that calculation and I want the lower bound. So if I want the lower bound, I'm going to say it's going to be the lower bound multiply the lower bound because as I said, it's working parallel. So for the smallest answer, I will work with these 2 lower bounds. And for the biggest answer, I will work with the 2 upper bounds. So then, if I'm going to look, so it's going to be 74.5 multiply 205. And if I do that calculation, I'm going to get 15272.5 and do not approximate it because it's in limits of accuracy, just leave it unapproximated. Okay. I want you to stop the video and I want you to do question number 3. I want you to take note that after I started doing it, I realized that there is a meter missing. So just put that in. So again, you can continue the video as soon as you are finished. Let's start with question number 3. The length of the side of a square is 12 centimeters. Now, it's always good to make a picture. Okay, so it's a square and every side is 12 centimeters. Look at your units also. Correct to the nearest centimeter. So if they say nearest centimeter, it's meaning 1 centimeter. So it's meaning 1 divide 2, and that's 0.5. So I'm going to add for my upper bound, and I'm going to subtract for my lower bound. And that's what I'm going to do. So it's 12 centimeters. I'm taking the 12, and I get my upper bound, and I get my lower bound. And what will be my upper bound? It will be 12.5. And what will be my lower bound? It will be 11.5. Okay. Now calculate the upper bound for the perimeter of the square. So for this calculation, they want the upper bound, and they want it for the perimeter of the square. Now remember what I said to you. If it's addition and multiplication, if you want the biggest, you just work with uppers. And if you want the smallest, you just work with lower bounds. But in this case, the 4 is fixed. It's a constant. So I will just multiply with that upper, which is 12.5. And my answer will be, and let's just quickly calculate that one, and it will be 50 centimeter. And that is part A. Now remember, in part B, I was adding that meters. Okay. So Mr. Leo measured the length of a rope and record her measurement. I just want to get another color. Correct to the nearest 10 centimeters. So remember, this is in centimeters, and I added a meter there. The upper bound for her measurement is 12.35 meters. Now, before I go to this part, I want to first just show you by looking at this example. Say, for example, I'm giving you this upper bound, and I'm giving you this to the nearest. I'm giving you this also, this part. And I'm asking you to find this part. What will you do? Now, just think. You add 0.5 to get that 12.5. So now you will just do the reverse. So what is the reverse of add 0.5? It will be subtract 0.5. So I will take 12.5, I'll subtract 0.5, and I will get 12. Okay, now this is exactly what I'm going to do in this question. Now just be careful for your units. So if I start with number B, let's just take yellow. So number B. So it's correct to the nearest 10. So let's just say correct to nearest 10 centimeter. Okay, so it's going to be that 10 divide 2, and that is going to be 5. So I add for the upper and I subtract for the lower. So that will be the upper, and that will be for the lower. Okay, but the upper bound for the measurement is 12.35. Now, I will just want to take it back. Let's first take the 12.35 meters, and let's just convert it first to centimeters. Now, I always like, and I always do this, I always write my table: kilometers, meters, centimeters, millimeters. There's 1 0, there's 2 zeros, there's 3 zeros. And if I go to this side, I multiply, and I go back, I divide. So if I go from meters to centimeters, I multiply 100. So what will I get? I will get 12.3. Okay, let's just get that correct. 12.35 centimeters. Now, don't forget that that is the upper bound. I'm looking for not the lower bound, so this is my upper bound. I'm looking for the original number. So if I was, instead of adding 0.5, just go and subtract 0.5. So I will get 1, 2, 3, not 0.5, 5. I said it incorrect. So just go and say, instead of adding 5, I subtract 5. So it's 1, 2, 3, 5, and I subtract 5, and then I get 1, 2, 3. You can even put a 0, and this is now in centimeters. But they want the answer in meters. So now I will just convert back from centimeters to meters, so I divide by 100. So I'm going to say 1230 divide 100, and I'm going to get 12.3 meter. That was the original number. This is for me a very good question. It's just something different I saw by going through a lot of question papers, international question papers, and looking at the latest trend. Okay. Let's continue with example 2. On one day, the number of members using the exercise machine was 40, correct to the nearest 10. Each member used the machine for 30 minutes. Okay, so this was 40. This was for 30 minutes, correct to the nearest 5 minutes. Calculate the lower bound for the number of minutes the exercise machines were used on this day. Okay, so let's start. So first find the lower bound and the upper bound of the individual numbers before you do the calculations, as we always said. So if this is to the nearest 10, that white, which I showed you there, I divide 2 into 5. So I add 5 for the upper and I subtract 5 for the lower. Okay, and this is what I did here. It's the 40, so add 5 for the upper, subtract for the lower. And then the other one was 30 minutes, the yellow one. So now in this case, it's to the nearest 5. So I always divide by 2. So take that 5, divide 2, I get 2.5. So now I will add 2.5 and I will subtract 2.5. So if I add 2.5, I get this for the upper. And if I subtract, I get this for the lower bound. Okay, now calculate, and now I must just read the question. The lower bound. So always just check what they ask for the number of minutes. Now, sometimes I think this upper and lower, you make the question more difficult because it's actually a very straightforward question in the sense that you're just going to say 40 machines multiply the time. So it's just a simple multiplication sum. But I just bring the bounds in, the upper and the lower bounds in. But remember what I said, multiplication as well as addition, it works parallel. And that's what I indicate to you there. Do you see? Parallel. In the sense, if I want the lowest bound, do you see? The lowest bound for the machine use, I just say the lower times the lower. Okay. And if I want the biggest, I would have said upper times upper. But they asked the lowest. So answer the question. So I'm just going to put it in. It's the 35, multiply the 27.5, and this is the amount of minutes that the people are on the machines. Okay, this is a typical one. Now this, I want you again, we're going to do the same. I want you to stop the video. I want you to do number 1. And then I will first do number 1. And then you do with 2 the same and with 3 the same. But it's always good to first try it on your own before you are watching the video. Okay. Okay, but I'm going to start with number 1. Emily's height is, and this is a very plain one, it's just that you are not sometimes used to, and I showed it in this example, usually you are used to the nearest 1, to the nearest 10, to the nearest 100, to the nearest 1,000, but it can be another number also. So Emily's height is 175, correct to the nearest 5. Okay, so if you say correct to nearest 5, then you're just going to say 5 divide 2, and I'm going to get 2.5, and I'm going to add for my upper bound, and I'm going to subtract that amount for my lower bound. And let's just do it. So it's going to be 175, and I like always to put that up, and I like to put this down, to just but to not get confused between all this. So if I add for this upper bound, I'm going to get 177.5, and I can actually stop there because why? So run on the upper bound, so therefore upper bound is 177.5, and that was in centimeters. Okay, if they asked for the lower bound, I would have just subtract it and get 172.5, but they did not ask that. They asked the upper bound. So that was a very simple one. But I think it was a nice one due to this 5. Okay, but I think I also did it there in that example. Okay, let's do the same with number 2. You try it, and as soon as you are finished, you can continue the video. Okay, I'm just going to clean, and then I'm going to do number 2. Okay, so number 2. A rectangle measured, and it's always nice to have a picture because it's practical sums. So it's 43, that's the longest one, and 28, that's the shorter one. Both correct to the nearest centimeter. So if it's correct to nearest centimeter, it means 1 centimeter. And it's 1 divided 2, and that's 0.5. And again, remember, add for your upper. I'm always writing it, subtract for your lower. Okay, so we can do it with that numbers now. And just mark it, otherwise you get confused. So say upper and say lower. Otherwise, just remember the top is upper. So this is going to be 43.5. And this is going to be 42.5. And the same with this one, if it's 28, and then it's the upper, and it's the lower. And this upper is going to be 28.5, and it's 27.5. Okay, so calculate the upper. So they're looking for the upper bound of this because it's the area. So it's actually the area of rectangle. And what is the area? Just know, you know that the area, just write it there. It's length times breadth. And it's a multiply. And now remember what I said. They want the upper. I said, then you work. It's a parallel. Then it's upper times upper. And if you want the smallest, then it's lower times lower. So remember, with multiplication and addition, it's like in parallel. Okay, I'll come to division and then I'll show you it's not parallel. Okay, so basically, it's just going to be 43.5 times 28.5. And if I multiply that, and again, don't approximate, 1239.75, and that's in centimeter square. And that's how you do it. Very, very nice. Okay. Again, I want you to do the same with number 3. Stop the video, and as soon as you are finished, you can continue the video. This is nice. I think sometimes because it's practical sums, it's also making it a bit more challenging. But first try to see the basic, the simple sum, and then focus on the upper and the lowers. Okay. So, let's paint a rectangular wall. Now, it's more or less the same. The length of the wall, so it's more or less the same. Can you see, they like sometimes just repeating something. So I like to just make a sketch. Okay. The length of the wall is 20.5. So this is 20.5. And this is 2.4. 2.4. Okay, and it's all in meters. Both correct to 1 decimal place. Okay, now so remember what I said, correct, we did it, to 1 decimal place. 1 decimal place is always 0.1 divided 2. 2 decimal places will be 0.01 divided 2. 3 decimal places will be 0.001 divided 2. Significant figures. There you must look at the number before you can decide. Okay, but this is going to be 0.05. And again, I'm not going to write that now. Okay, now, and why I put this, because this is a bit on the other level now. So, but let's first do this before we tackle the practical part. So for the upper bound, and we're just going to find the lower bound. So the upper bound for this one is going to be 20.55. The lower bound is 20.45. and then it's 2.4, and then the upper bound and the lower bound, and it's 2.45 and it's 2.35. Okay, now let's go on. Both correct, so I have all my values. Now 1 liter of paint covers an area, so they want me to work out area of exactly 10 meters square. Calculate the smallest number of 2.5 tons of paint. He need to be sure all the walls. He will need to be sure all the walls is painted. Now this is it's a bit a more difficult one, because it's first the smallest amount of tons, because it 1 liter of paint. This is my liter of paint. That is just going to be small. It's just going to be in, oh, that is not looking like a tin, but this is going to be in 2.5 liters. Okay, that is one. But it can cover 1 liter can cover 10 square meters. Okay, now it's like, must I work with the upper or must I work with the lower? Now you want to make double sure the paint is enough. Now to make double sure the paint is enough, first work out the biggest possible area. Okay, so the biggest area, and that will represent the upper bound. And remember what we say, it's parallel. So it's going to be this upper, so it's going to be upper times upper. So it's 20.55 multiply 2.45. Okay, now if I multiply that, I will get 50.3475. That is the biggest possible area of this rectangle. Okay, now I can start by saying, I want to see how many liters I need. Okay, how many liters? How will you do that? You're just going to take this area and you're going to divide it by 10 first, just to see how many liters. Now, if you divide it by 10, you get 5.03475 liters. Okay, that is at least you need that liters. But now you cannot just go to a shop and say, I want 5.03475 liters. No, they have specific tins. Now the smallest tin, or the tins that they recommend, is the 2.5 tin. So I will show how many tins. Okay, I'll show you now. So now you're going to take this 5.03475, you're going to divide it by 2.5. Now, before I write the correct answer, you are going to get 2.0139 tins. Now, again, you cannot go to the shop and say, I want 2.0139 tins. No, you either must buy 2 or you must buy 3. Now, it's almost like we call this rounding up. If you buy 2 tins, a little bit part can maybe still not be painted. Maybe that little part will still, okay, I'm struggling to get that little part. Let's just get that. Maybe then that you sit with a little part that's not painted. So you can sit with extra paint, but you must at least make sure that everything is painted, the biggest possible area it can be. So now comes the practical. They say, calculate the smallest number of paint you will need to be sure to walls. Okay, the smallest number of 2.5 liter tins. So therefore, 3 tins. Sorry, he's going to sit with 1 tin, which is almost full, but that's the only way he can paint that little corner there, to make sure the full rectangle is painted. And that's how. So it's like, in this case, we are going to round up. I'll show you later an example, I think in part 2, where I'm going to round down. So always just think of the practical aspect and bring that into your calculation, because that's your final answer. And this will be the end of part 1. So part 1 are really just as I showed you here, and let's just go. Most of all the sums which I did here was just involving addition and multiplication. In the next video, I'm going to focus on a bit more challenging, and that's going to be subtraction and division. I will again advise you, if you don't have a copy of the textbook Y equals mx plus c to success, you can go to one of the following bookshops and buy your own copy.